Alright, here's what I noticed on problem number 1. I have a quadratic trinomial. Because it's take 2. Because it's quadratic, the possible number of turning points are 1. The lead coefficient is positive in the standard form, so the right hand is up. The degree is even, so the left hand is the same as the right hand. The degree is 2, so the possible number of x-intercepts are 2, 1, or 0. The actual y-intercept is the constant term, so it's 5. So we know 1, 2, 3, 4, 5, there's the y-intercept, and we know the right hand is up and the left hand is up. So now let's find the actual x-intercepts, and we get those in the factored form. So quadratic trinomial can be factored into 2 linear binomials. The lead coefficient is positive 1, so we can write x and x. We need to find factors of 5 that multiply to positive 5 and add to positive 6. Plus 1 plus 5. We set this equal to 0 because x-intercepts occur when y is 0, and we solve each of these linear binomials. So minus 1, x equals minus 1 is one of them, and x equals negative 5 is the other. So now we have the information we need. We can draw a sketch, a possible polynomial that meets all the requirements. Looks like that. Okay, let's take a look at the next one. The next one is a cubic trinomial. So the possible number of turning points are 2 or 1. The right hand, let's see, the lead coefficient is negative. Oh my goodness, you're right. 2 or 0. I had that. There it is. 2 or 0. The lead coefficient is negative, so the right hand is down. The degree is odd, so the left hand is opposite. The possible number of x-intercepts, 3, 2, or 1. The actual y-intercept will be the constant term, which is, the constant term is 0, so we know that. And the actual x-intercepts we get from the factored form. So I think that we need to factor an x and a negative out of each of these terms, and we'll end up with positive x squared minus x minus 12. And now this quadratic trinomial can be factored. X and x, two numbers that multiply to 12 and add to negative 1. So plus 3 minus 4. Now the x-intercepts occur when y equals 0. So we set each of these to 0 and solve them. And we'll get x equals 0, x equals negative 3, and x equals 4 as the x-intercepts. And we know the right hand is down, so it must look something like that. There's a possible sketch.